use this all year?
No.
Okay, so there's a lot of different types of probability, different ways of finding stuff, different formulas to use at different times. So today we're gonna focus on what's called permutations and combinations, and also the fundamental counting theory. So those are some key terms we'll talk about today. So on this little short, easy question that we got there, it says you got 3 pairs of pants and 2 shirts. How many possible outfits do you have?
6.
6. So all you did to get that was multiply, and that's called the fundamental counting theory. I don't know why they have to give it a big fancy name like that, but you just, yeah, multiplication
They gotta be
works,
difficult.
works for me. So you could just say your 3 times 2, got you that. Probably in middle school, you might have made tree diagrams. Could have made a tree diagram here. Either way, with your pants or your shirts first. We'll say shirt number 1 and shirt number 2. So with shirt number 1, I could wear pants 1, pants 2, pants 3. With shirt number 2, I could wear pants 1. Remember doing these a long time ago? Pants 2
Nope.
and pants
I never
3.
did these.
And so then you just would count how many you have out there on the end of your tree diagram. 1, 2, 3, 4, 5, 6. That's another way to do it. Okay, everybody good on that? Easy schmeezy. Erase my lovely tree diagram. What else did I want to say about that question? Got a different book for this unit that we're doing. Okay, so I'm going to show you, as soon as my page turner turns, 2 different license plates here. This one has got an F, H, V, and a 194, so that's one license plate. My other license plate just has 4367. Okay, so what this says here is that this is Maryland license plates in the year 2004. So the one on the left was the year 2004, and 1912 is the one on the right that just has the 4 numbers. So they got a more modern version of their license plate showing us, and then an old one there. And the question says, how many more of the newer style plates were possible than the old one? So we have to be able to figure out how many plates were possible there. So if we have a letter in that spot, how many possible letters could there be there?
26.
26 letters in the alphabet, so you could have any of them, so there could be 26. So on a license plate, can you have repeat letters?
Yeah.
Yeah, so just because you used an F here doesn't mean this one can't also be an F. So how many possible letters could go here? 26, and so then again, 26. So far, using our fundamental counting principle, we'd have 26 times 26 times 26. Now we change to numbers. How many digits are there?
9.
Are you sure?
10, no, you can.
Okay, because 0 is a digit, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 digits. So times 10, you can have 10 digits there, and you can have 10 digits there. So obviously, fixing to be a pretty big number when you multiply all that out. So tell me how many possible license plate combinations there were in the year 2004 in Maryland.
At least 10 times 26.
$17,576,000.
Yes, sir. Okay.
I had to look at the number for a minute.
So then when we go back to the 1912 year, they've only got the numbers. So they've only got the digits, so 10, and they've got 4 of them. So what's 10 times 10 times 10 times 10?
Yeah.
10,000. Okay, so the
Oh,
question,
it's 4.
the question said, how many more of the 2004 style plates were possible than the 1912 style? So what would I do with my 2 answers now to find out how many more were available?
Subtract.
Add them.
Subtract them. So what do we get when we subtract there?
17.
566,000.
What?
The 17,566.
Okay, So pretty good on our multiplying and using the fundamental counting principle, right? Everybody good?
Yeah.
Easy schmeezy. Alright, so the other two words, the next one we'll talk about is a permutation. Whoops, pushed the wrong button. Permutation, and this is after I teach you how to do it without the calculator, then we'll learn how to do it with the calculator. So a permutation, it's very similar to the fundamental counting principle, and most of the time they're interchangeable. You can use the fundamental counting principle or you can use a permutation. But one thing, and you're gonna wanna write this, and this is a big deal, is that when you're using a permutation, order is important. Okay, so that could be like a case of a race, you know, like if you win and you get a gold medal, that's a lot bigger than getting third or fourth, right? So order is important on that. The other one, the combination, order doesn't matter. We'll talk about that one in a second, but gotta pay attention to order here. So if I said we got 3 items and we just wanna figure out the way to choose, hold on. There are 3 ways to choose. Oh, that's not what I wanna do. Yeah, let's go back to that. Suppose you wanted to find the number of ways to order 3 items. So there are 3 ways to choose the first one. So if I've got 3 items here, blank, blank, blank. This first one could go in any of the 3 spots, right? But now the second one, there's only 2 spots left for it to go, right? And then the last one, there's only 1 spot left for that to go. So that would be 3 times 2 times 1, which would get you 6. Now, what I just did there, here's another new word for you. Have you seen anything ever that looks like that?
No.
3 not from coding.
No. And it's also not 3! It doesn't mean scream.
Yeah.
Okay? That exclamation mark in math is called factorial. Took Christian a while to get it. It's called factorial. And all you do with the factorial is take your biggest number and then you multiply every number underneath it until you get to 1.
I was just thinking what a different class might be thinking from when I'm young as a kid.
Miss Toller's just down the hall and all she hears is 3!
Okay?
We're doing some intense math over here.
Yep. Okay, so let's do one that's a little bit harder than 3, because you know that one wasn't too bad. So let's say we got 12 file folders, one after another in a drawer. The directions say use the fundamental counting principle to count the number of permutations of the 12 items. Okay, so here's what we would know about that. I got my first file folder could go in any of the 12 spots, right? Now my second one can't go where the 12 went, so how many spots are left?
Left 11.
And then my next one,
Mm-hmm.
so what are we writing? What's the math word for it?
Factorial.
Factorial. So that's the same as 12! Oh, just kidding. 12 factorial. Now, if you had to multiply that all out by hand, you could do it, but that wouldn't be super duper easy. Now, you could also just type in your calculator 12 times 11 times 10 times 8, but there's a factorial button. So let me show you where the factorial button is.
Isn't it math?
And this comes in handy on the ACT also. So I'm going to go ahead on my home screen where I do my add, subtract, multiply, divide. I'm going to get 12. So I got my 12 up there. Then to get to factorial, I'm going to hit math. Okay, and see those headings up there at the top? Look, there's one that says PRB, PROB. That stands for probability. So I'm going to move it over to probability, see? And there's my factorial down there at number 4. So what is 12 factorial?
479,001,600.
Can you imagine having to do that all by hand? Now in that math probability function, there's also, that's where we'll go whenever I teach you in just a second how to do the permutations and combinations. It can do those in there too. Alright, let me get back to my home screen. Alright, so let me give you the formula first off for a permutation. You got a little n, a big P, and a little r. And the formula to figure it without a calculator is you would do whatever's in the n place, you would do that factorial on top, divided by, subtract them, factorial on bottom. Okay, so if we said there's 10 students in a race, what the n and the r mean? The n is your total number, and then the r is how many you're wanting to choose. And now what do we remember about order on a permutation?
It's important.
It's important. So n will be our total number of people in the race, and r will be the top places that we're concerned with. So it says 10 students are in a race, first, second, and third places all win medals. And how many ways can the 10 runners finish first, second, third, no ties allowed? So you would set this up as we've got 10 runners. We want to find out how many ways they can finish three, the top three. So to do this first off by hand, on top I would have 10 factorial. And don't use your calculator for anything yet, I want to show you some tricks. On the bottom I would have 10 minus 3 factorial. Now here's what you're going to say, 10 factorial is too big to do without a calculator, because that's 10 times 9 times 8 times 7 times 6, oops, and so on. So it is going to be a pretty big number up there, but let me show you something cool. Let's write it all out. Okay, then on the bottom, 10 minus 3 would be 7 factorial. You see anything I can ninja? Hey, everything from the 7 down goes out, doesn't it? So now 10 times 9 times 8 I can do, because I know 9 times 8 is 72, and then times 10, that would be 720. So with those 10 runners, and we're concerned on putting them in first, second, third, there are 720 different options for how that race could be finished. That's kind of mind-blowing when you think about that. It's not usually that many. Okay, I'm going to show you how to do that on the calculator now. What you'll have to do before I get mine pulled back up is on your home screen where you add, subtract, multiply, and divide, you'll have to put your n in first. So just put a random 10 there, and then we'll go to math probability.
Did you mean to put 10 in that end spot?
Yes, I did. Thank you. I don't know what I was doing on that. Thank you, thank you. Now I can find my marker. There it is. Alright, so my normal add, subtract, multiply, and divide screen, I put my n first, so I'm going to put 10. Then I'm going to hit math, move it over to probability, and then look at number 2. This is a permutation, it's got a capital P, so I'm going to go pick that one, hit enter, and now I got to put my R in. So I'm going to hit a 3. 720. Are you alright on the calculator? Oh, he just did that. Our phone droppers today.
I wasn't even on it, did he?
So he wasn't either, it fell out of his pocket. Okay, so combinations is the other one. And on combinations, order doesn't matter. P-O-E-S, can't spell. And I teach this every year, and I still catch myself having to go back and look at my notes to see, does order matter here? So it's, make sure you've got that in your notes and you can keep it straight. So I'll just go ahead and throw you the formula at it now. You've still got your total number.
Let me guess, NC.
And a capital C. And then your R's, how many you're choosing. So the formula is very similar. N factorial on top. But on the bottom, you've got an R factorial. And then you've got the N minus R. factorial, so it's got that one additional piece on the bottom. Okay? So if I said, we've got 13 items and we wanna take 4 at a time. So we're just picking up 4 random items at a time, so it doesn't matter what 4, the order of them doesn't matter, so we would say, show you how it all works without the calculator, 13 total items, 4 combinations. So 13 factorial, I'm just gonna go ahead and write it out so I can see if I can get anything to cancel. 4, 3, 2, 1, and then on the bottom, keep up with my mouse, it's hard for me to see it. 4 factorial for my R. And then n minus r, so 13 minus 4 is 9. Okay, so I can ninja here everything from the 9s down. So then on the bottom, I'm gonna do that one first because that one's something my brain can handle. 4 times 3 is 12 times 2 is 24, so I've got 24 on the bottom. 110 times 12, what is, help me out with 13 times 12 times 11 times 10.
17,160.
17,160. And then when I divide, what do I got? 715. Now again, you could have done that just using your calculator. So you could have hit 13 on your home screen and then math probability. But this time you go choose NCR, NCR, okay? Alright, so I'm gonna give you a couple of scenarios here, and you tell me if it would be a permutation or a combination. So that means you're telling me if you think order is important or not. Order is important, it's a P. Order is not, it's a C. Okay, so let's say the good old Mr. Reed, the chemistry teacher, is dividing his class into 8 groups. Each group is going to submit a drawing of the molecular structure of water. He will select 4 of the drawings to display. And how many ways can they be displayed? So first thing I need to know, is the order important? No, because 4 gets picked, 4 gets picked. It doesn't matter, there's no prize for being first, second, third, or fourth. So it would be a C. So he divided us into 8 groups. So we need 8 combinations of 4. Okay, either use your calculator or do that by hand and tell me how many different ways he could pick our drawings. Seven, very good. So what you got? Alrighty. So we're gonna draw a winner from a total of 25 tickets in the raffle. The first ticket drawn wins $100, the second wins $50, and the third wins $10. And how many different ways can you draw the 3 winning tickets? Does order matter?
Yes.
You bet your boots, there's a big difference between $100 and $10. So order matters, so that means it's a permutation. Okay, so I said we sold 25 total tickets, so that's our N. Permutation, we're picking 3 winners. 13,800 different options. It's hard to wrap my head around that sometimes. I'm like, well, there's just 25 tickets. But when you start mixing up the first one with the last one, the first one with the next to the last one, the first one, it's a lot. All right. Any pretty easy stuff? Any questions on any of that? So tomorrow, it's gonna get into just some more basic, the rules of probability, like what's the probability of flipping the heads and all that type of stuff. Okay, okay.
Everything's a 50% chance it either happens or it doesn't.
Those P's and R's and factorial buttons come in handy on ACT, save you a lot of time.
I can tell why. Having to write all these out would not be fun.
Yeah.